All right, so I'm going to go over the study guide for our Unit 4 test. This only is going to include the trig stuff. So we left off geometric mean and Pythagorean theorem. That is on a quiz, though, that you've got to take. You should have already taken. Anyway, here we go. So this one, I could just pick either one to start with. It doesn't really matter because I need to solve for both. So I just picked solving for angle A. Got to get my pen going. Angle A. All right, I'm going to label just like always. So this one is opposite to where my angle is. This one is the hypotenuse, opposite of the right angle. So I am going to use my sine function. The sine of the angle, angle A, you could call it angle theta, is opposite over hypotenuse. I'm going to enter that in my calculator. This is, remember, when I'm finding angle, I'm going to always be using the second button in my inverse trig, okay? So I'm going to enter in my calculator 12 divided by 13 equals second and then sine. That's what I enter in my calculator. When I do all that, I get the answer is angle A would equal, I'm just going to round off to the nearest degree. It didn't give you directions, 67 degrees. Now, I could continue on and do another trig function to get C, but I could also think about the idea that this is a triangle and all angles need to add up to 180. So I could take a shortcut and say angle C, let me label this correctly, angle A. So angle C would equal, well, A and C together need to equal 90, so I could say 90 minus 67 would equal angle C, which is 23 degrees. Sorry, I'm doing this in third period, my planning. All right, so that's how I could get that quickly. Little shortcut there. All right, this is a multiple choice, but for your study guide, you still need to show the work. So I've got an angle degree here. I'm given that. I got to find everything, so it doesn't really matter where I start. So I'm going to say this is opposite of that. I could solve for the hypotenuse first. So I'm going to say that that is the sine of 20 degrees equals opposite over hypotenuse. Okay. When variables on the bottom, I'm going to switch their places. So I'm going to divide 20 by sine of 20. So in my calculator, I'm going to enter 20. Let's do it this way. I'm going to enter 20, divide by 20, sine is how I enter it, and then equals. Make sure you hit the equals or else you'll just get the sine of 20. And that came out to be 58 degrees, 58.5. That is the side length of AB. So AB is 58.5. And I'm going to look at my multiple choices. And AB, 58.5. That is, well, it's either this one or this one. But let's look at it. Let's think about this. If this is 20 angle, what would this have to be? It would have to be 70. So I can then choose this guy. And I don't really have to go on and figure the other side because of the multiple choice. All right. Number 3, finding x and y. So you got two options here, using special right triangles. I'm going to do that second. First, I think most people would probably not use special right triangles, so let's look at it that way. So I'm going to label this. It doesn't matter again where I start, but I'm going to say this is opposite. This is hypotenuse. So that is the sine of 60 equals x over 4 square root 3. Okay. I need to multiply to solve this. So 4 square root of 3 times the sine of 60 is my answer for x. How do I enter that in the calculator? I'm going to key it like this. 4, then I'm going to hit multiply, then I'm going to hit 3, then I'm going to hit the square root button, then I'm going to say, I can say times again, then I hit 60, then I'm going to hit sine, and get an answer. So all of that should come out to be, that comes out to be 6. Okay, so now this is 6. Now I might tend to just forget about that hypotenuse side because it's got the radical in it. And now I could say, well, this one is adjacent and opposite. So that is tangent. So I could say that the tangent of 60 equals adjacent, SOHCAHTOA, sorry, my bad, 6 over y. Okay, again, switch their places, and answer is 6 times, no, I'm sorry, let me rewrite it. Y equals 6 divided by tangent 60. These switch places. So now divide that, and I have, it turns out to be 3.5. Okay. All right, now if you wanted to do it specials, if you may want to just skip forward if you know you're not going to try specials. But if you were doing it with special right triangles, I'm going to, let me erase this here and clean this up. I'm going to notice that this is a 60-30 right triangle. So that means this is the small side. I'm going to relabel that X. This is the hypotenuse is twice the small size. This is the small side times square root 3. Okay, so if 4 square root 3 is twice the small side, then this is half of that. So 2 square root 3 is equal to x. So the small side is 2 square root 3. And then the long side is 2 square root 3 times the square root of 3. So the square root of 3 times the square root of 3 is 3. So 2 times 3 is 6. And so in this case, you get 6 either way for that side. But the other is 3.5 versus 2 square root 3. So when you put that in your calculator, you should get that. Let's go and try it out. 3 radical times 2 equals 3.46. So it rounds up to 3.5. All right, that is that one. All right, so we got a little bit of, oh, wait, I'm going in the wrong order. Let me go this way, 4. Okay, so I'm gonna look here, I'm gonna go back to red. I'm gonna look here, this is the adjacent side, this is the hypotenuse. So that is cosine of 41 equals adjacent over hypotenuse. When I go to solve this, that's not one of the choices. So when I go to solve this, what happens? I multiply y times cosine 41, and that would equal x. So this would be your correct answer. Angle B. Okay, again, I'm looking for an angle, so I'm going to know right away. I'm going to be hitting that second button. I'm going to use inverse trig. Set it up. This is opposite. This is adjacent. That is tangent. Spell it right. The tangent of the angle in question is SOHCAHTOA 14 over 8. Okay, and that turns out to be that theta equals 60 degrees. The way I'm entering that is 14 divided by 8 equals second button, then tangent button. All right, traditional trig problem, I'm solving for a side. I'm going to label opposite adjacent, so it's another tangent of 64 equals opposite over adjacent, multiply 11 times tangent 64 to get my answer. So that came out to be 22.6, and depending on how you're being asked to round it, this like didn't specify. All right, the towers, you got 452 meters tall. The woman is 90 meters away. Find the angle of elevation between the woman and the top of the tower. So right there. So I'm going to label adjacent and opposite. So tangent of some angle is SOHCAHTOA 452 over 90. Enter it in my calculator, inverse trig function, and I get 78.7. Round to the nearest degree. Here's where you could miss it. It's round to the nearest degree, so that needs to go up, and that's going to be 79 degrees. All right. 90-foot wire. 72-foot tall phone pole. What is the angle that it makes with the ground? All right, again, missing angle, inverse trig. Tangent, oh, I just picked one. Let's try labeling. Opposite, hypotenuse, so that is the sine of theta. The angle is 72 over 90. Okay, put it in your calculator. 72 divided by 90 equals second sine. Those are your key entries. And you would get 53 degrees. All right, to the back page. We got a tree, 12 yards tall, cast a 15-yard shadow. What is the angle of elevation that the sun makes with the ground? Missing inverse trig. So again, opposite, adjacent, SOHCAHTOA. TOA, tangent of the angle is opposite over adjacent. Okay, I'm going to enter 12 divided by 15 equals second tangent. Okay, doing all that, I get that theta equals 39 degrees. Okay, and these two, we said that the sine of an angle is equal to the cosine of its complement. So these 2 degrees need to always equal 90 degrees. So find out what you need. So 90 minus 50 is 40. Whenever you see that, they should always be complements of each other and add up to 90 degrees. No biggie there. All right, so we've got a proof. This is a formal proof proving that the sine of an angle, sine of one angle is equal to the cosine of its complementary angle. So here, that's the first statement was given to you. The other statement that's given is that one. Okay. We're using angle addition to say that 40 plus 90 plus angle B is equal to 180. So we're going to be trying to find out what is angle B. So triangle sum is what tells us we can do that. Triangle sum theorem. And then we're doing subtraction. So what would make sense that we're trying to find out angle B? So we're going to subtract 90 and 40 from 180 and find out that angle B is 50 degrees. Okay, and then if we kind of look at our end goal is to show that sine of A is equal to cosine of B. Well, we've got this figuring cosine of B, so it looks like I need to figure out what the sine of A is. So the sine of A is opposite over hypotenuse, so the sine of A is equal to opposite over hypotenuse. All right, that's definition of sine. So I'm noticing here that each of these equal y over x. So I'm going to use cosine, definition of cosine to find that one. And then you could say substitution, transitive property. If sine of A is y over x and cosine of B is y over x, then they should be equal to each other. And that's how you're formally proving that the sine of A is equal to the cosine of its complement. All right, and that is all. And I'll put this, I had this up in class, if you just want to have it real quick as a reference. Those were all the answers. Remember, this study guide will give you 100 points formative as a classwork grade, but you do need to show all the work, which I've just shown you. All right, have a great day. We'll see you later.